Hi guys, my name's Ben. I came to software from a kind of a roundabout route. I actually learned to program on board a warship in 2003 when I looked a bit more like that than I do now. Started with Python and then I got into Haskell probably about 2010-ish, and now I'm working at Standard Chartered. Now, a few of you in this room will have seen a talk that I gave that has the same front page. I promise it's not the same talk. One of the bits of feedback I got was that the talk covered a bit too much material, so I'm going to drill down into the area of software architecture. But I'm hardly going to talk about software architecture. So let's see how this goes. So, not going well to start off with. All right, I'll use these. So, first of all, I'll give a quick sort of overview as to how I came to be talking about this kind of thing. I think the combination of military experience and tech is not a very common one, so I think there's some hopefully useful lessons to learn. You can come and tell me afterwards if that's the case. I'll come on to that in a minute. So this is a section of the talk that's quite important. And then I will talk a little bit about architecture, but not so much. And then a reading list of things that I've been looking at to get to where I am with all these ideas, and then I'll try and leave as much time as I can for a Q&A. So, genesis of the talk. So, obviously, as I said, military experience and IT not terribly common, and I have worked for startups. I've worked for big companies, and I've had a few kind of not so great experiences working in tech. In terms of working for failed projects or companies that had a bad culture, all these kinds of things. So a few years ago I started to get some inklings that maybe I'd learned things in my previous life sort of a decade and a half ago that actually still apply. So this is where the ideas of the talk kind of comes from. And now I'm committing an absolutely cardinal sin here. I'm an ex-Marine and I'm about to talk about an Air Force guy. Now this, it's being filmed as well, so I could be in real trouble here. So Colonel Boyd started life as a fighter pilot in Korea in the 1950s, and this guy has cut an absolute swath through military theory, through business, through he's been hugely influential, even though he only got to colonel. And the reason for this is that he dives into some real kind of fundamentals that are applicable across multiple different domains, and I'm going to argue that they're quite applicable to software as well. So, can I just have a quick show of hands? Anyone who's heard of the OODA loop? Everyone from Standard Chartered, yeah, we've heard. So, OODA loop stands for Observe, Orient, Decide, Act. Now, I've put this as the first slide when I'm talking about Boyd, but actually this is kind of the culmination of all of his work, of all of his kind of, he's a voracious reader. He's read up on, von Clausewitz, everyone in military history, Musashi, and this is his kind of, his thing, right? It's the Boyd OODA loop. Now it seems, fairly simple. It's just a basic feedback loop. You see what's happening in the world, you kind of relate that to the context of what you're in, you decide what to do about it, and then you carry out some sort of action. However, as with all things simple, it's a little bit more complicated, and Boyd's, so it's often presented like this, but Boyd's formulation in his actual writings, which I'll come on to a little bit later, he's a little bit more in depth. So this was on my previous talk, so I promise I wasn't lying earlier, this is not the same talk. So in Boyd's formulation, actually the most important part is this area here, which is basically how you integrate and how you integrate new knowledge and new information into how you kind of process the world. And the aim of doing that in here is that once you have this kind of broad kind of level of experience and all of the things that go through this loop, you can actually often bypass the decision point and go straight to intuition. So I'm sure as an experienced software developer, you've had the experience of looking at a a piece of code and just feeling like, don't like that. I mean, maybe it's something to do with, when I was a Python developer, you always used to see code that was like indenting, sorry, you guys are that way, indenting like that, and that would give you a bad feeling, right? Well, that's basically all of the time you spent going through this loop and refining your mental model in here gives you the ability to have some intuition about what you're seeing, and you don't have to kind of make a weighty decision. Another example of this is in the martial arts. So I train in Brazilian Jiu-Jitsu, or have used to. And when you roll with somebody in Brazilian Jiu-Jitsu, they skip this bit entirely. When you're deciding where to put your arms and legs, they already know, and it only takes a couple more loops around the loop, and you're in some sort of inescapable chokehold. So John Boyd's sort of seminal work is Patterns of Conflict, which is I think something like a 3-hour briefing. Now, Boyd used to travel around Washington giving this briefing to generals and to government ministers, and if these kinds of people can put aside 3 hours to listen to a colonel talking about stuff, there's some meat in there. I believe it's available on YouTube. The slides are available. One of Boyd's things was he never really wrote much down, so his body of kind of knowledge is passed on largely through sort of secondhand people that used to work with him. So the kind of the driving kind of force behind this Patterns of Conflict is, what do we want if we're running a company, or we're having our own business, or we want the freedom to be able to shape and adapt to changing circumstances so that we can survive on our own terms and improve our capacity for independent action. I like that. So that's something to aim for, right? It's if you're running a company, if you're a startup, you're looking to get to a point of profitability where you are surviving on your own terms, and then you can choose where to go. That's one example. So, and the implication that comes out of this huge slide deck is that these ideas of variety, rapidity, harmony, and initiative, and the interaction between them are the key qualities that go into being able to reach your goal. So when you look at these sort of 4 ideas, variety and harmony, they're quite difficult to harmonize. If you have harmony, you tend to think of harmony as something that's, everything's very similar, and variety is something that's sort of a bit chaotic. So this is why the interaction between these ideas is quite important. So another of Boyd's papers is it's a tiny little paper. It's 7 pages long, but it's absolutely brilliantly written. So what we're obviously trying to do when we're going through that OODA loop is we're developing our mental model of the world around us. And we do that by taking in new observations, compacting them all down, and sort of generating new kind of representations of the world. And likewise, these new things are then broken down, and the cycle goes again and again. And that's why the paper's called Destruction and Creation. And I mean, really, you can't avoid challenging yourself. You can't avoid challenging your ideas. You can't avoid learning new things. I mean, nobody probably would be sitting in this room as a Haskell programmer if they hadn't kind of, I mean, certainly for me, Haskell wasn't my first programming language. I'm guessing for most people in this room, it's not the case either. And for me, I came to Haskell because I thought it would make me a better programmer and teach me new things. And to do so, I had to break down some of the things that I thought I knew about programming as well. So, and then there's this idea of, harmony and variety. You have to have a little bit of chaos in there. You can't be in a flat kind of neutral environment. You have to have a little bit of chaos to kind of perturb. It's like machine learning. You need to have a little bit of noise in there to be able to move around your kind of problem space. And this happens both internally and also in the external environment that you see changing. So Destruction and Creation, 7 pages long, quite big type, well worth a read. So another kind of thing that I came across that I really liked, there's a book by Robert Cringely called Accidental Empires about the rise of startups in Silicon Valley. But the formulation I prefer, obviously, is this idea of commandos, infantry, and police. So you've got different sort of timescales of operation, right? Commandos are the first people in, the most uncertain environment, the quickest changes, most important missions, most chaos, damage and surprise, and less process, right? And then you move into the second wave that comes in. So this is, you've perturbed your environment, you've created a load of chaos, a load of noise, and then you need guys to come in and, the guys that have done all that, they're not really interested in kind of process, and they want to go and do the next chaotic mission and blow stuff up. So then you get the infantry who come in, who are, a little bit more established, obviously still kind of very much on the sharp end, but, this would be your kind of, you've got your MVP done if you're in a startup, you've got your MVP done, and now you actually need to, systemize it, productionize it, package it. And this is where, stop process comes in, and you need to start having systems in place. And then following all that, you move into an even slower kind of operational cycle. So imagine this OODA loop going around. These guys are very, very quick, very decentralized. These guys are a little bit less quick, less decentralized, more process. And then you've got the bureaucracy that comes in, which if anyone works in a big company will be very familiar with. So this is about kind of consolidation, and I would argue in this phase, your ability to kind of generate chaos and therefore new ideas is mitigated slightly and maybe tempered. So that's the book I mentioned, Accidental Empires. So I think Facebook got it wrong, right? Like move fast and break things versus move fast on stable infrastructure. Actually, you break things, then you carry on moving fast, and then you get to stable infrastructure. So if I ever see Mark, I'll mention that to him. And this is a very good, if you can't be bothered to read the whole book, and I actually haven't read the whole book, I must admit, this is quite a good overview of the ideas there. All right, so architecture. That says architecture. Right, so anyone who's worked in a big company will be familiar with this view of software architecture. What you do is you take a big pile of money, you put it in the middle of the floor, and then you burn it. And then every couple of months when the cycle comes around and you need more funding, you get more money and you throw it on the pile, and then you just end up looking like that dude there. And oh yes, that's true. Yeah, this is, well, there's some fairly large cracks in it. So software architecture. Yeah, not really that fond of this view of architecture. So, but important question. Right, why do we bother with software architecture at all? I remember when I was a sort of, junior in development terms, but maybe not quite junior in years because I started software quite late. I went into a company and I didn't really appreciate the need for, why do we have to use this library versus that library? Why can't I just take whatever I want? And I think the important question about why we bother with software architecture is because, if you do achieve success, you do have to go from that commando, infantry, police model, right? Not everyone in your company will be in one box. Your whole company won't move from one box to another. If you've got a stable bureaucracy, strong and stable, you'll still need people at the sharp end generating new ideas, or if you don't, you'll be in serious trouble. So I think when you decide why you need to bother with software architecture, you need to know what phase you're in, and if you're multiple teams, that answer might be different depending on which team you speak to. So one of my other interests, besides trying to conflate military learning with software, is psychology. So there's this concept called chunking, not from Wikipedia, from the field of cognitive psychology. So this is where you take individual knowledge, you integrate it through the orient bit in your OODA loop, and you're able to then compose things together, right? So an example from my earlier example of martial arts, I'm still trying to put the basic building blocks of where my arms and legs go, Whereas the guy who's better than me, who's been doing it for a few years, has integrated that into, I'm going to go and do this move. And I'm trying to do all of those things at once, and he's doing one thing at one time, and it's all kind of chunked together. And I think, as Haskellers, I think that this is one of the things that really attracts people to Haskell. People get the Haskell bug, and I think it's because of this. This is an inherently pleasing process to go through. So, if you equate chunking to the kind of the type system hierarchy, if you're looking at a functor, if you've been doing Haskell long enough, you know what it can do, you know what it's for, you know the rough meaning behind it, and you're able to kind of take that chunk, and you're not then looking at the imperative code underneath it and to say what steps is this thing going to. You're going from what's it doing to what is it. And exactly, this is from the same Wikipedia page. So you're creating higher order cognitive representations, right? Mental models. And it's a paper from the 60s. I think this, idea that people have 7 plus or minus 2 has been slightly debunked now. But the underlying theory that, you want to be able to lump things together so that you can operate at a higher kind of mental level is still a valid thing to take away from this. And then mental representations are the kind of longer term idea behind chunking. So, when you start something, you've got this, the 4 phases of competence, whatever it's called. You've got unconscious incompetence, conscious incompetence, conscious competence, and unconscious competence. So you go through this kind of process of not knowing what you don't know, knowing, I think there's a US Secretary of State that talked about this at some point. And the way that we go from not knowing what we don't know to unconsciously just being able to do stuff is that we build our mental representations of what we're doing. So, in Haskell, obviously, we learn our basic kind of fundamentals. We put those into practice, and then we get some experience, and then eventually we generate a bit of intuition. Like, oh yeah, I see this particular type of problem. I might need this monad stack, or I might use this MTL constraint. And that idea of building up this experience so that you have this kind of general base upon which to build intuition enables you to choose the right abstractions. And I think we're very lucky as Haskellers because the right abstractions are mathematics, and these have been rigorously studied and smacked around, and we're building much closer to what the fundamentals are. I think abstractions should be as deconstructed as possible. So I would much rather think in terms of functors than say an observer pattern that you have to visually look through a whole page of code before you figure out, I get what they're trying to do now. Right, if you see, this is a functor instance, you know exactly what you're looking at straight away. So this is where, the destruction and creation paper kind of feeds back into kind of software architecture, right? You want to be able to do as much as you need to do to achieve success, but you want to do that in a way that remains harmonious. You don't want to be achieving success in the short term and creating loads of technical debt. So you want to be able to apply the larger kind of chunks to what you end up with. And that enables you to move quickly without breaking things or causing yourself problems that will make yourself not be able to move quickly in the future. And so here we go, this first bit of code. This, to me, is the core kind of abstraction that we all care about, right? When you look at the OODA loop, right, we have things happening, we decide what to do with those things, and from that we generate a new thing, knowledge, or state, in the case of the left fold. So everyone's familiar with, left fold. I mean, push is a subscription API, so you subscribe to new things, you do something with them. WebSocket, I should have put pusher in there, sorry, Will. But this is, this is a very, very common pattern, right? You can do this with, you can apply this chunk to multiple different things that you see in the real world. Destruction, you break down the old state, and the event that comes in, the new thing that you see, and creation of new state. So, I think OODA is a hugely applicable paradigm to think about. It's simple, it's ever-present, it's fractal in that, you have large-scale OODA loops of a company, say, operating over months or years. You have your very low-level development tools set up where you want quick feedback and you want your, fly check warnings in your Emacs buffer. Those are all OODA loops, and they all compose. And the smaller, faster ones are, the longer, slower ones are built upon multiple layers of smaller, faster ones. So, events, state, fold, command. So, events obviously are your observation. State is your kind of all that giant load of stuff in the orientation bit. This is your understanding of the world, your context, what you understand of the problem domain you're in, and then obviously you decide what your new event comes in is. That's your fold command. You take your event and your old state and you generate a new state from it, and then you act, and in a startup that I worked at before, we actually called these commands. So an intention to do something from the outside world in the web interface or something was a command. The command comes in and generates potentially many events, and then that is then folded into the database, and that's basically event sourcing CQRS. And honestly, I think unless I had some real constraint, if I'm building anything nowadays, I would usually go for some kind of event sourcing idea, because it enables you to ask the right questions. So you store your granular data. You never kind of throw anything away. If you're doing some sort of traditional web app where you have like a CRUD app, and a post comes in from your webby thing, and you do an update in the database, well, you've basically thrown away a bit of information. You have the new state, but you don't have what happened. You don't have the semantic kind of what did we do here? What was the occurrence? And the other thing that event sourcing gives you is the ability to go back and answer different questions, ask different questions of your data. So you can go back and say, right, if I change my fold, given that this is what the concrete things that we've observed, if I change my fold and my state, what does the world look like now? And it also gives you the ability to, accounting systems are all essentially event sourcing things. They give you the ability, I work in a bank, and one of the very important things that you have to do is to be able to say, what's the view of the world as we see it now, but also what's the view of the world before this event came in. So we might have an event that comes in so from a point of time A, you might have an event that comes in and is relevant to a point in time before that, but you need to know, what does the world look like at time A, and what does the world look like now when we understand that something else has happened? So that's quite a useful superpower to have. And then in the front end, you can use the same ideas for the Elm architecture. So you have events come in, you have a pure function that updates your state, and then your state is declaratively expressed into the HTML. I personally prefer Halogen and PureScript, but the idea is very similar. So this is all the same as it's a fold. It's the same as the CQRS and event sourcing idea on the back end. And the best thing is you get to reuse your mental chunks in processing both of those things. So, folds all the way down for me. It's, you read any papers, and eventually you're going to come across all these kind of, all these terms, F-algebras, free monads, catamorphisms, hylomorphisms, interpreters, semigroups, monoids, function composition. These are all things where you're taking things that you reason about individually, you're smushing them together, and then you're wanting to reason about them in the same way. A special shout out to metamorphisms, because a metamorphism is wrong way around. A hylomorphism is an anamorphism followed by a catamorphism. So you generate something, and then you contract, and then you break it down. Used in, I don't know where it's used, I guess, comonads, maybe. I'm sure I've seen a hylomorphism in the wild. I've never seen a metamorphism in the wild. So that's the other way around. That's destruction and then creation, which I was talking about earlier. So you have your catamorphism, and then you have your anamorphism. So you break down a chunk of stuff, and from that stuff is born something else, which then probably goes on into another cycle of being broken down. And that's funnily enough, the only space I ever came across this. I was reading Destruction and Creation, and I thought, this sounds very much like a hylomorphism, but the wrong way around. And a metamorphism, I don't think I've ever seen one in the wild, but the one paper that I did find basically equates this to stream processing. So that's basically what we do day by day when we're walking around. We are a stream processor, and this is the state. So I quite like that. Yeah, Foldale. So yeah, that's my learning from, unfortunately, not the Royal Marines, but mostly the Air Force about software architecture. It's all destruction and creation. Reading list, Boyd's autobiography. Fantastic book, really well written. Robert Coram was one of his kind of acolytes, very close associate of his, so really understands the genesis of it. Boyd, as I said, for somebody who basically wrote the book on military kind of theory, if you like, this guy is so revered that the US Marines actually had him help write their warfighting manual. Now, as I said before, right, for a Marine to even acknowledge the existence of an Air Force weenie is something quite amazing. So for somebody who had such a incredible output, he didn't write much down. Patterns of conflict is slide deck. Destruction and creation is his little seven page long gem. There are a few others dotted around, but honestly I'd start with his autobiography. To answer Pepe's question about why doesn't this work in big companies, team of teams, this is about the experience of General McChrystal in Iraq trying to combat Al-Qaeda. If you want to understand about this kind of idea of mental models and this tree of kind of knowledge and how that works, Josh Waitzkin is a chess prodigy, Brazilian Jiu-Jitsu black belt, world Kung Fu champion, and has a very, very good understanding of the kind of the meta stuff that goes on when you learn. Accidental Empires, yeah, you could skip that one, to be honest. Go read the blog post that I had earlier. And then, if you actually do want something about software, and I apologise for talking about stuff that's not really about software, Building Evolutionary Architecture is actually quite good by ThoughtWorks. And then a little shout out to Graham Hogg, who's an ex-Royal Marines intelligence officer. He's written a very good book about how you build this kind of culture into companies, about asking the right questions and enabling your OODA loop and unsticking things. So yeah, I think that's me done.